Okay, here we go. Unit 7, Computer Science from Barron's book to prepare for the AP test. Some good multiple choice practice. I did have, I think, a record 14 responses on the form out of 21. So we're up to 2/3 of you guys actually filling out the form. And these are assignments that we should have had done like a month ago. And I haven't given you any new work. So I don't feel bad. But let's go through these questions and make sure we actually understand them. Even if you got them right, sometimes you might have got lucky. But recursion's kind of tough to kind of get the hang of. And some of these problems, it's kind of a bit of work to kind of trace out how the program would go. Which following statements about recursion are true? So it's kind of general. Every recursive algorithm can be written iteratively. Yes. Tail recursion is always used in divide and conquer. Now, tail recursion is when you do something before the recursive call. Okay? Before it calls itself again, you do the thing. If you do it afterwards, which is common, I forget what that's called, but it's not tail recursion. Divide and conquer is to first, break things up and call itself, and then conquer. Like this is when you do something. So this is not tailed recursion. This is the other version. So that one's out. In a recursive definition, a process is defined in terms of a simpler case of itself. Yes, it calls a simpler version of itself. So it should be 1 and 3 only. Okay, let's see. Number 2, which of the following, when used as the body of the method sum, will enable the method to compute 1 plus 2 plus whatever all the way up to the nth number correctly for any n greater than 0? So we're trying to figure out what should do that. Now, usually we need a base case. So we're probably going to start at n and work our way down to n equals 1. So this would be your base case, right? Base case. You got to check to see if something's true. So they have base case. This one doesn't have a base case, which means it's going to keep going into negative numbers, which is not what we want it to do. It's going to go to 0 and negative, and it's going to just go on infinitely. So that one's bad. This one returns 1 if it hits a base case. Otherwise, it returns n plus some of the next smaller number. That's good. So this makes sense. Keeps going to the smaller number. Eventually it gets to the base case, n equals 1. This one right here, this part, I guess, goes towards the base case. But then there's this other part that just keeps calling sum of the same number over and over and over again infinitely. So this one is bad. There really should just be an in there. So it's going to be 2 only. Okay? So you got to look at this code and see if it makes sense to you. All right. Number 3, which refer the method string recur. So it's probably some kind of, they like to use generic names, probably a recursion algorithm involving strings. So you pass a string in, and when the string length is less than 15, if the string length is less than 15, then you print out the string. And then there's no else here. And then so it just prints it out once it gets to less than 15, but then it keeps calling string recur plus star. So it keeps adding onto the string, which means if it's 15 or bigger, this just will never happen. This is going to keep getting bigger and bigger and bigger and bigger forever, which is going to happen infinitely, which is not good because there's no else here. You would need an else. And you would want to somehow make it smaller, not bigger. And even if it's less than 15, it'll print it out, but then it's going to keep making it longer, and eventually it stop printing out, and it'll just keep going forever. I mean, no version is going to work. I mean, So, I mean, if I had else here, then if it was less than 15, it would work. It would just print one thing one time. Well, no, because that would go infinitely too. So it's going to be without error. No strings will ever work in this. It's flawed. Okay, number 4, refer to method str recur. Sounds like another string recursion algorithm. You pass a string. If the length is less than 15, this looks very similar to last time, print it out, and then add a star to it. Now, here's the interesting thing. If it's less than 15, it'll do this until it's more than 15, and then it doesn't do anything. So this is the base case, and sometimes we get, or the base case is that s is greater than or equal to 15. Okay, and there's no if for it. There's no check. We're actually checking for the non-base case. If it is the base case, then nothing happens. The program's done. So, but this will, s could be less than 15, and then this will make it go towards that because it's inside the if. It'll increase it and keep calling it. So this is going towards the base case, and so this should work. When will the method terminate without error? For all strings. Now, some of these say only when the length of the string is less than 15. Well, it works for less than 15, but not only when less is 15. Greater than or equal to 15, it works, but not only. When it's an empty string, it works, but not only. Okay, so that word only makes a difference. Okay, so number 5 and 6 refer to the following method result. It returns an int, it takes an int. If the int equals 1 that you are given, it just returns 2. Otherwise, it returns 2 times the call to itself times the next smaller number. What does the result? What value does result 5 return? Well, my best recommendation is to just trace it out, see what happens. So we have result 5. It checks if it equals 1, and it doesn't. So then it's going to be 2 times result 4. It checks. Now it doesn't do the 2 times yet. It calls this, checks result 4 is not equal to 1. So it's going to return 2 times result 3, and then checks 2 times result 2, and it checks, and then 2 times result 1, and 1 equals 2. So what it's going to do is it's going to say, oh, there's a 2 there, and that's going to give you a 4, and that's what this equals. This equals 4 right here, so it's going to be 2 times 4 is 8, and that's what goes into here and returns from that, and this one's 2 times 8 is 16, and that goes up here, and 2 times 16 is 32, and that's your final answer. This is that kind of stack idea where we go down, 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 and then we finish all the way backwards. So it gives you 32. In other words, it might be interesting to say, well, what's the general result of this method for any number? It looks like it's this number. It's 2 to the n. 2 to the n is what this method is going to do. If n is greater than 0, how many times will result be called to evaluate result, including the initial call? Well, just look at this one right here, and it gives you an idea. 1, 2, 3, 4, 5 times. Right? 5 times. So this one was 5 calls. Now, and then that equals the n value. So I'm going to go with that. There you go. Okay, number 7, mystery. This one says it takes 3 different ints, n, a, and d. It checks if n equals 1, and then if it does, it returns a, and it's done. Otherwise, it returns. Okay. So let's see. And then it calls it works towards the base case, right? It decreases n if n is a bigger number, and makes it smaller until you eventually will get to the base case, and then this will finish. What value is returned by mystery 326? Well, I think the best way to do this is to write it out. Mystery 326, and you might write the variables next to it, NAD, and n doesn't equal 1. So it's going to return D, which is 6, plus a call to mystery of 226. The n value goes down 1. Checks if it equals 1. It doesn't. So this is going to return the D value, 6, plus mystery. It's going to decrease the 1 again. And then this time when it checks 1, it returns A, which is 2. So this goes back here, it gives you 2. 6 plus 2 is 8. That goes back to here. 6 plus 8 is 14. So the answer is 14. I don't know how you're getting these answers without writing this stuff out, unless you're just a genius. So I don't know. I've been doing this a while, and it's hard for me to figure these out without writing them down, especially this recursive stuff. Okay, so the next problem is number 8. Refer to method F. So here's a method F. It takes two ints. If n equals k, if they equal each other, it just returns k. That's the base case, right? So it's good to understand that's what we're going towards. Now, else, if n is bigger than k, it does this. Otherwise, it does this. So it's two different options in the recursive part. What values are returned by F68? Write it out. F68. F68. Okay, it gets called. They're not equal. So then that's going to give you, that's going to call F, and it's going to, it says if n is, this is k, this is n. It says n, if n is bigger than k, which it is here, then it does this. It says, okay, we're going to keep k the same, but we're going to subtract k from n. So that leaves you with a 2. So then it goes back up here and it checks, okay, are they equal? Nope. So then it says, is n bigger than k? Nope. Then you're going to do this. You're going to call f, and you're going to subtract n from k. That's going to give you 4. Now, all these n's and k's are based off the last call to that method. It's not the original k. Comma 2. It checks to see if they're the same. They're not. So it goes down here and says, is n bigger than k? Nope. So it goes down here and says, do this. You subtract n from k, you're going to get 2, comma 2, and you should be like, ooh, that's good. This goes up here and it says, is n equal to k? And it says, yes. And it says to return the k value, which is this value here. But nothing else. There's no other operations or anything. This is your answer. You're done. So that's it. 9. What does recur do? So here's a method. They're just saying, what does it do? Now this one, I gotta say, I got stuck on. So public int recur, you give it a 1D array of ints, and you give it an int. And it creates a new variable inside called t. And it says, if n equals 1, then just return the first thing in the array. Okay. Otherwise, set t equal to recur, call the same 1D array, but decrease n by 1. And then it says, if the, now that, okay, n equals 1. So this is going to keep happening, and then it's going to come back and start to finish these. So I'm going to start, I thought, let's try and figure out what's happening by just creating, a scenario. So I'm going to create an array of some integers, not too big, put some different numbers in there. Don't make them all in order or whatever. I mean, if it's some in order, put a 0 in there. I'm going to set n equal to 3 and see what happens. Now the index of each of these, the spot in the array is 0, 1, 2, 3, 4, 5, right? So let's see what happens if we do this. Recur, we give it this array x and the in value, which is 3. They're not equal. So then it says, okay, well, t equals recur, and it uses x and it decreases n by 1. Okay, now none of this stuff happens right now as these calls to recursion are being called, because now we're stuck in the next recursion call. That has to finish before we come down here. So it says, okay, does n equal 1? No. So then it comes down here and it sets t equal to recur x1. And then it says, is n equal 1? Yep. And so this returns x0, which is the first thing, which is a 3 right now. Now that gets returned. Now now we're at the last step here. Now we're going to do this for the last step. If x n minus 1, so this was n right here, is bigger than t, so t equals 3, by the way, because this returned 3 to this. So t equals 3. And it says if x n minus 1, which would be x0, is bigger than t, they're not, it's equal, then return that. Otherwise, return t. So then this returns t, which is 3. That that finishes this recursion call, which then goes back up here and sets this equal to 3. And then we're at this point now that we finally got the t value. Now we got to say, well, is x n minus 1, which would be 2 minus 1, is the first spot bigger than this? If it is, you return that. Otherwise, you return this. It kind of looks like we're looking for the biggest thing. So then that gets returned to this one. And I guess we're done. Now, it seems like, well, hold on. Recursion 3. So I think we got to do that. We got to do this stuff for this one now too. No, I think that was the first. It goes up here. Does it check it again? It might check it again. Anyways, it looks like it's looking for the biggest thing, the largest value, but it starts at like the in value or something. It starts at like if n equals 3, it says if n equals 1, it just returns the first spot because that's the biggest thing. Otherwise, it looks in the second spot. So it doesn't even check the first spot. If that's biggest, then that's it. That's the answer. Then it checks this one versus that one and checks that one versus that one, I think. And t equals, so it goes down 1, but then it's trying to get to the end. It's trying to get to n equals 1, right? So it checks 2, then checks 1, and then it finally returns this. And then on the next step, it checks the next spot up to see if that one was bigger than the last one. And if it is, you return that one. Otherwise, you return the other one. And then I think, I don't know if it's doing it, but it looks like, the thing about it to me is that they are only doing it for the first chunk of this. It's not doing it for the whole thing unless you give it the size of the array in, which it didn't say that. Maybe n is x, an array of, oh, it is. So n is the whole array. So it's going to look through the whole array, and I think it's looking for the largest thing because it keeps comparing to the previous thing and updating it. So if it finds the largest value in x and leaves x unchanged, it doesn't change any values in it. So I think that might be it. It doesn't look for the smallest. It doesn't sort it. It's not sorting it. It returns x0 or xn minus 1, whichever is larger. No, I think it looks through the whole thing. It's just looking for the largest one. But this is actually what it says. They're saying that this is the correct answer. I'm not quite, I don't know. I feel a little confused about that one. The explanation, you could look online. I put the explanations, and it says if there's only one element, then returns that element. Having the recursive call at the beginning of the else part of the algorithm causes the if part for each method call to be stacked until t eventually gets assigned to x0. I feel like it's supposed to be the other way. X0 gets assigned to t. The pinning if statements are then executed and t is compared to each element of x. The largest value of x is returned. So they say that okay, never mind. The answer is A. I don't know. Yeah, the answer is A. So I don't know. That was challenging, but apparently only 2 people had a question about it. So I guess you guys are set. Number 10 says which best describes print string method below does. What does it do? So it doesn't return anything. It says it's called print string. It takes a string. If the string is greater than 0, then it calls itself. Don't confuse this with it actually printing. It calls itself with substring. So this is the next. This is the second letter because it's like they're kind of like arrays. They start at 0. The first letter is 0. So this is the second letter in the current string to the end, because there's a couple versions of substring. One, you give it two numbers, and one's the beginning, and the second one is right after the end. If you just give it the one integer version, it starts there and gives you the rest of the word. So this takes off the first letter, and then it calls it. This doesn't happen yet. Okay, so you got to understand about recursion. It calls itself. So now we're going back up here. These don't happen until we finish the last recursive call. Unless this happened before it, then it would start printing these out. So it says, like for instance, I'll do an example, like a really simple one. I mean, if they give you one, you might try that one, but I'm going to do my name. All right, Sam. I'm going to see what it does. It says, okay, so the length of this is 3. So it says it's bigger than 0. So it's going to call print string, but it's going to just give me the second letter to the end. And then it says, okay, well, is length bigger than 0? It is. So it's going to call print string again with the third letter to the end. Is the length of string bigger than 0? It is. It's 1. So it calls it again, print string, and then it's nothing, which is fine. It does that. Now, once it's no longer bigger than 0, then that's done. And it goes back up here and it wants to finish the last recursive call where it prints out 0 to 1, which is just the first letter. Then it goes up here and it wants to finish this one and it prints out the first letter of that string, 0 to 1. Then it goes up here and it calls just the first letter of that string. So what happens is it prints them all out backwards. It prints out the backward version of the word. So prints S in reverse order. I mean, the best way to figure that out is to just kind of trace it out with a simple example. 11, refer to the method power. Base, so they're telling you what they want you to do. Base of a non-zero real number. So can't be 0, essentially. Non-zero. The exponential is an integer. And the base is a double. And it should return the base raised to the exponent power. So it's trying to mimic, an exponent being applied to a problem. So it says if expo equals 0, return 1. because if something's raised to 0 power, the answer is always 1, right? Else, if expo is greater than 0, return the base times the next smaller power, right? Because 2 to the 8th is the same as 2 times 2 to the 7th, right? Which is the same as 2 times 2 to the 6th. And so we're breaking it down into all the separate 2's so that we get the final answer, right? And it decreases the exponent 1. Else, do what? It says, which code correctly completes the method power? So what's the only other possibility here? The expo equals 0, the expo is positive, else the expo is negative. Now, you got to have a little math, algebra 1 knowledge here. If an exponent is negative, like if we did 2 to the negative 8th, well, that's actually 1 over 2 to the 8th. And what we're doing here is instead of multiplying by 2, we're dividing by 2. Or you could think it was multiplying by 1 over the base every time, right? Right? So we need to get something that does that. I think it's got to be the base times 1/2, or the base or the base divided by the next base, or 1 over the base. Let's see. 1 over the base, that's a good start, right? 1 over the base times power base expo plus 1. Now, here's the deal. When it's a negative exponent, we want to eventually get to the exponent of 0. So we got to work towards the base case. So we got to add 1 to the negatives so it eventually gets to 0. This one will go infinitely negative. I think the right answer is A. That looks good. These ones, it shouldn't be base times. This one, the exponent just stays the same all the time. We got to work towards the base case. Okay. 12. Consider the following method. Do something, and it takes an integer. If n is greater than 0, you call do something n minus 1, and then you print something out, and then you call do something n minus 1 again. So this one's kind of interesting. I would trace this out. This is not super simple. It says what will be the output following the call do something 3, which look at all these answers. So let's trace it out. Do something 3. Right away, 3 is bigger than 0, so it calls do something 2. Now, it doesn't go to these yet, because the call to do something 2 goes back up here and says, well, it's 2 bigger than 0. It is. And it calls do something 1, and then it calls do something 0. So finally, we get to 0, and we're done. Okay? So then it goes back up here to the last call of do something, and it prints out what value. Let's see. It prints out the n value 1. It prints out a 1. So we get a 1. Then it calls, after that, we're not going up here yet. Now we're up to here, and it calls do something 1 again. The same call. And do something 1 says, well, 1 is bigger than 0. So let's call do something 0, which doesn't do anything. And it comes back up here. So far we've printed a 1. So then we come up here and it says, print out the value right here. So we're going to print a 2 out. All right, so we get a 2. But then it calls do something 2. Now do something 2 calls do something 1, which calls do something 0, which terminates, goes up here, prints out the 1. So we get another 1. Then calls do something 0, which does nothing. Then goes back up here. So do something 2. All right, so then we're done there, and then it goes back up here, and it prints out. Let me see. Yeah. Hold on one second. Let me see if I. Okay, so this prints out a 1, and it goes up here. The other thing that you can do is kind of keep track of this. This is the first thing. This was the second thing. This was the third thing. This was the fourth thing. This was the fifth thing. This was the sixth thing. Actually, hold on. I missed something. This was supposed to call do something 0 after. Yeah, this was called do something 0. So this was the 6th thing, and then okay, so it called do something 0, prints out the 1, calls do something 0. Then we go back to the previous step, which then prints a 2, but then it calls do something. This is a mess. Then it calls do something 1. Let me just get rid of this right now. So this was the 6th step. Seventh step. Now do something 1 prints another 1 out. So we have a 1. And it calls do something 1 again. That doesn't do anything. 7. Then it goes up here. This is the 8th step, and it prints out a 2. And then after it prints out a 2, it calls do something 2, which calls do something 1, which calls do something 0, which does nothing. Comes out here, prints another 1. Okay, so that's where right here. And then it calls do something 1 again, which calls do something 0, which does nothing. Then we get up here and we print another 2. So I think we get a 2 here, and then we call do something. Okay, so then no, it doesn't print anything out yet. Then it goes up here and it prints. I'm losing track of it. The right answer is right here. I think I'm getting close. Then it prints a 3 out. I think I gotta start my. Let me see if we can start my little tree again, because I'm losing track here. Okay, so I'm gonna just use a capital D for the do something. So do something 3. This is kind of what the book does, or the answers do. Do something 3. It's bigger than 3. It calls do something 2, which eventually will do some other things, but do something 2. Let's. This is how they kind of do it. Now, what does do something 2 does? Well, it calls do something 1, and then it's going to do a couple of things. But then do something 1, what does do something 1 call? It does do something 0, and then a couple things. And then do something 0 just doesn't do anything, right? Because then n is equal to 0. So it comes back up here. It prints the 1 value, right? Because this was n minus 1. This is your n on that step. It prints out that, calls do something 0 again, doesn't do anything. So we get a 1. Then it comes back up here. It prints out the 1, or no, the 2. And then it calls do something 1, which then we got to do another do something 1, which calls do something 0. Does a couple things. Do something 0 doesn't do anything, just like here. And then it prints a 1 out. Okay, so we're up to 1, 2, 1. And then it calls do something 0 again, and do something 0 doesn't do anything, so it's done. So we come back up here and it prints a 3 out. So we're here at the 3. And then it calls do something 2. And then we're going to have the same process play out over here that we just did right here exactly. So we're going to get another 1, 2, 1. Oh my gosh, that was hard. But I don't know. I guess 10 out of the 14 of you who responded Felt good about it. It was challenging for me. Okay. 13. A user enters several positive numbers on a keyboard and terminates the list with a sentinel. That's like the end value to know we're done. And usually like a big negative number would make it really obvious. Right even method reads those integers and outputs the even integers only in reverse order as they're read. So reverse order is going to work well if we do the printing out after the next recursive call. So they give you an example. We go through here. This is the last one. Here's the first even, and then here's the next even, and then here's the last even, and prints them out backwards. Assume that the user enters at least one positive integer and terminates the list with -999. Here's the method. Okay, all even integers on the list are output in reverse order, public static. So it's reading a value in. If it doesn't equal a sentinel, that's the base case. Base case is it does equal sentinel and we're done. If it doesn't equal sentinel, then let's do something. Let's keep calling it. Which code? Let's keep getting numbers until we get to the sentinel. Okay, which satisfies the post condition. Which one works? If the number is even, right? This is a way to check if it's even. If the remainder, as you divide by 2, this remainder modulus function, then let's print it out right now. It seems like it's going to print them out as it finds them, and then keep looking for the next one. We don't want it to do that. This one checks if it's even and asks for another number only if it's even. So this is only going to even take evens from the user. Unless the first one is odd. So that doesn't seem right. This one says, well, let's keep asking for numbers until we hit the end. And then let's go back, and the last one, it's going to finish the last recursive call. Let's check if it's even. If it is, print it out. So it's going to be 3 only. That's the only one that's going to work. And so you got to understand how recursion works. The order of these statements makes a big difference. Refer to the following recursive method, mystery. If n is less than 0, it returns a 2. Otherwise, it calls 1 smaller than itself and 3 smaller than itself. So again, I'm going to make a little tree thing here. So I'm going to call mystery. They say, what happens when you do 3? Well, let's figure it out. Mystery 3. 3 is not less than 0. So what happens is it calls mystery 2, and it also calls mystery 0. Right? And now mystery 2 is the first one, actually. This hasn't even happened yet. Mystery 2 gets called, and then it calls mystery 1, and then that calls mystery 0. And if n is less than 0, it's not yet, and then this calls mystery -1. Okay? Now, once we get to there, it returns a 2. Right? Now we're going to add these, okay? So now it goes back up here, and it calls mystery 0 minus 3 is -3, and that returns a 2, right? If anything is less, any n value is less than 0, returns a 2. So it adds those together, and that gives you a 4. Then it comes up here and says, okay, let's call also mystery 1 minus 3 is -2. That returns a 2. 4 plus 2 is 8. Then it comes up here, and this calls 2 minus 3 is -1. That returns a 2. 8 plus 2 is 10. Then it comes up here, and it calls mystery 0, which is not less than 0 yet. So then this goes to mystery -1, which returns a 2. And then we go up here, and this calls mystery -3 also, and that returns a 2. So that gives you a 4. So now we have a 10 plus a 4 for this last step, and we get 14. The answer is, oh shoot, what did I mess up? Mystery 0 if n is greater. That's right. This returns a 4. Oh, 4 plus 2 is 6. Gosh, dang it. And then 6 plus 2 is 8, right? And then 8 plus 4 is 12. At least my answer wasn't there, so I knew I did something wrong. But that's how it works. Like, that's how you show your work on these. This is a quick, sloppy way of doing it. But I don't know how you're figuring that out. But only one person had a question on that. So, I mean, I don't know. I had to go through that whole process to get that answer. I mean, it wasn't complicated, but I still had to do it. Okay. 15 and 16 refer to the following method. N is a positive integer. So it's going to return an integer. It takes an integer. The method name is called T. If n equals 1 or 2, it returns 2 times the number. Okay. Otherwise, it calls itself 1 minus itself and 2 times and subtracts them. So this is a lot like the last one. So it says, what happens with T5? Well, let's try it out. T5 says, okay, they're not equal. So let's call T4. And then that says, let's call T3. And that says, let's call, now we're going to have another step later on. And that calls T2. But this is, we're going down. This is the order it's doing it. That calls T2. Oh, we got 2. So that's going to return 2 times 2, which is 4. But then we go up here and we're going to subtract the call to T3 minus 2 is 1. And that returns 2 times the n value, which is 1, which is 2. So 4 minus 2 is 2. So we get a 2 out of that. And then it comes up here and it's going to subtract a call. 4 minus 2 is T2. That returns 2 times 2 is 4. Okay, now here there's a 2 right here now. So 2 minus 4 is negative 2. Then it comes up here and it says, okay, let's call T5 minus 2 is 3. Now T3 calls T2. And then that returns 2 times 2 is 4. And then it says, okay, but then we have to subtract 3 minus 2 is 1. So it gives you 2 times 1 is 2. So 4 minus 2 is 2. And that's what goes right here. So what we have here is we have negative 2 minus 2 equals negative 4. That's your answer. Now it says for the method called T6, how many calls T will be made, including the original call? Well, I mean, we could count T5 and see if we think we can predict it, but it'd be interesting at least to count it. One, and this little tree right here makes it super easy to count. 1, 2, 3, 4, 5, 6, 7, 8, 9 calls when we did T5. Now T6, I mean, maybe we should just make another little picture real quick. So T6 would be T6 calls T5, calls T4, calls T3, calls T2, which is done, minus T1. That's the other call to that. And this calls minus T2, which is done, right? T2. 2 and 1 is the base case. This calls T3, which calls T2, and then minus T1. So that one's done. And then this right here calls T6 minus T4, which calls T3, which calls T2. And then we're done with that one. And then this calls T1. And then this calls T2, and then we're done with that one. And then I think we're done. So how many calls is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 calls. I mean, I don't know. Seems like the best idea is to write it out. Okay. But only 2 of you guys had a question on that. I hope you guys wrote nice little trees. I mean, even if you look at Barron's study guide explanation, they're drawing these things. They're not saying, "Oh, we got this cool trick," that'll, I don't know. Okay, 17 says F1 and F2 are in the same class. So there's 2 different methods, F1, F2. So this is going to be kind of interesting. It takes 2 ints. They both take 2 ints. It says if A equals B, then just return B. That's your base case. Right? And it says otherwise, return A, the first number, plus a call to F2, which is this guy. And then this guy calls F1. So it's like recursion, but with 2 different methods where one calls the other one, the other one calls the other one. So it says what's going to happen with the F1 3. Okay, well let's write out F153. Says, are they equal to each other? No. So then it's going to return A, which is 5, plus F2, and it's going to take A1 down to 4 and leave B the same. Now in F2, this is referred to as P and Q. And it says if P is less than Q, then return P plus Q. Otherwise, return P, which is 4, plus F1, called F1, and you're going to subtract 2 from P to get 2 and leave Q the same. Now back up here in F1, this is your A value and your B value. It says, are they equal? Nope. So now we're going to return the A value here, which is 2, plus a call to F2. We're going to decrease it by 1. And so that's going to make it 1. And we're going to leave the other number the same, 3. So it goes up here and says, this is now P and Q again. Now, is P less than Q? It is. So now we're going to return those two numbers added together. 1 plus 3 is 4. So finally we get a 4. It goes back up here. 2 plus 4 is 8. Okay, that goes in here. 4 plus 8 is 12. That goes up here. 5 plus 12 is 17. Which is not on there. So I made a little mistake somewhere. Going too fast. 1 plus 3 is 4. 4 plus 2 is 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 5 is 15. Gosh dang, a little tiny little mistake. But again, I don't know how you're figuring that out without drawing a little tree there. Okay, number 18, consider the method foo, which takes an integer, returns an integer. If x either equals 1 or 3, just return the value of x. Otherwise, you're going to return x times a call to foo where you decrease it by 1. So hopefully it's going to go towards that. Assuming no possible integer overflow, what will the value of z after executing? What will be the value of z after execution of the following statement? So z is just this. So foo is calling, we're going to call foo with an inside call to foo, 2 calls to foo. Okay, so now we haven't done any of the recursion yet, but well, so foo calls that. So foo says if x equals 3, that's your x, and if x equals 3, you just return 3. So this is just going to give you a 3. Okay, now this isn't equal to that, so this is going to call 4 times foo 3. Now foo 3 gives you a 3. And those multiplied together gives you 12, and 3 plus 12 is 15. Now, that's not the answer yet. So now we're going to call foo 15 finally. Okay, so that's just kind of the beginning. Now, foo 15 says, is it 1 or 3? Nope. So we're going to do 15 times foo 14. And then nope. So this is going to be 14 times foo 13. Nope. Okay. This is going to be 13 times foo 12. So it looks like we're going to get 15 times 14 times 13 times. This looks like factorial. And look at all the answers, and they almost all have factorials. It's going to stop, though, once it hits 3. So the last call is going to be to foo 3, and that's just going to return 3, and that'll be the last number. So the last one, it'll be 4 times foo 3, and then that'll just give you 3. So we never get the times 2 or times 1 that we usually get in the factorial. So you got to look at these creatively and be like, we almost got 15 factorial, right? Almost 15 factorial, but we don't get the last 2. Now, if you're in Calc BC, we've been simplifying factorials a lot lately. It's not a calculus thing, it's algebra, but 15 times 13 times 12 times all the way down to 3 getting cut off and not getting the 2 times 1, that's the same as 15 factorial divided by 2 factorial, because this would give you 15 times 14 times 13 times all the way down to 1, and this is going to give you 2 times 1. And what you'll do is you'll lose the last 2 times 1, and this will be what's left over. So the answer is A. All right, that was fun. 1920 public class int formatter. So it says write 3 digits adjacent to each other. Just writes 3 digits in, you give it a number and it'll write them 3 digits. Now, the way it does it, this almost seems kind of weird. And it just it prints them out. So essentially, if you gave it 321, it would divide by 100, which would give you a 3, and print that out. And then it would divide this by 10, which would give you 32. And then it does modulus 10, which is going to give you the 2. And then it's going to do the whole number 321 modulus 10, which is going to give you the remainder 1. So it's going to print out a 3, 2, 1. That's what that does. Insert commas in every 3 digits starting at the right. So what this is going to do is going to take a number. Down here they give an example. 2704861, and it puts commas in the right spots, starting from the right, and it does it for every 3 spots to write it the way that we like to write numbers, big numbers. So it's called write with commas. It doesn't return anything, but it prints things out. If the number's less than 1,000, it just prints it out because it has 3 digits or less. We don't need to put any commas, essentially, right? Otherwise, it's going to call write 3 digits in modulus 1,000. So like we'll do an example in a second, and then it puts a comma, and then it calls write with commas. So it calls itself again. So what it's doing is trying to break it down into the chunks of 3, putting commas in between, and it recalls itself. It uses this method right here just to write the chunks of 3 that we split out. But we got to split out now it says it's supposed to print its non-negative integer argument with commas properly inserted every 3 digits starting at the right. For example, it gives method write with commas does not always work as intended. However, assuming no integer overflow, which of the following integer arguments will not be printed correctly? Now, the ones that are less than 1,000, I think those are fine. There's nothing wrong with that, right? I mean, just prints them out. So it's not going to be those. So what we could do is we could just use one of these examples and see what happens. I think that's going to be the best thing. It says it's not going to work. So let's figure out what it's doing, and then maybe we can predict what's wrong with it and why it works sometimes and doesn't work other times. Because it's got to work for 4 out of 5 of these. So the first thing it does, it says write 3 digits. It does modulus 1,000 on this, okay? And what that would give you is this right here. It gives you the remainder, right? If you divide by 1,000, you get this, and then this is the remainder. That's what that gives you. It gives you the last 3 digits, and it just writes them. It goes up here and says, all right, let's print those out, 251, and then it puts a comma, and then it calls write with commas in divided by 1,000, which is going to give you the 251462, the first 6 digits, and goes back up here as less than 1,000. Nope. So it does here and does modulus 1,000 on this one, which is going to give you the remainder, and it prints those out, which is going to be 462. And then it puts a comma, and then it does this divided by 1,000, which is going to give you 251, which is less than 1,000. It prints it out. Now, the thing that you should realize is that it printed this one out first, then it printed this one out, and it was the first 3 digits that it printed out last. Now, in this particular example, that looks okay because the first 3 digits are the same as the last 3 digits, and it has a symmetry to it, and so it looks right. But if you were to do it with part C, try see what happens. It says, okay, do this modulus 1,000, which gives you the remainder, and it prints those out first, and then a comma, and then it calls write with commas with this, which is less than 1,000, so it prints those out. So it's printing out the chunks of 3, but backwards. It prints out the last chunk of 3. We do want to identify that the last chunk of 3 first, but we don't want to print it yet. So it doesn't work. It works if the first and last ones match. And in this case right here, the first and last ones match. So it'll work for that special case just because we get lucky. But this one, in general, it doesn't work unless things are really special cases. Okay? So now on 20, this is maybe the harder part. Which change in the code of the given methods will cause it to work as intended? So we got to figure out, well, what do we got to change here so that it'll work? Now, let's just interchange the line system dot out dot whatever in the right 3 digits. Right 3 digits is not the problem here. Right 3 digits just prints out 3 digits. So anything with right 3 digits, changes in right 3 digits are not necessary. Now this one says interchange the lines right 3 digits and right 3 commas in the method right 3 commas. In right 3 commas. In right 3 commas. We definitely want to make change in right 3 commas. So it's got to be B, C, D, or E. This says interchange, swap these 2 lines of code is what answer B is saying. They're saying swap these 2 lines of code so that it calls right with commas first. Let's see if that works with this one right here. If it calls right 3 commas first, then it says, okay, if the number is 365051, then it calls right with commas. It says divide that by 1,000, so it does this one, right? And then right with commas goes up here and says, oh, it's less than 1,000. Let's print that out and then put a comma, right? And then look at the next chunk and then we call right 3 digits with this, and it prints that out. So that one worked. I think that one works. The other one says change the test and write with commas to if n is greater than 1,000. No, because that'll just print whatever is greater than 1,000 out without even commas. That's clearly wrong. This one says in the method write with commas, change line, write 3 digits to in remainder 1,000 to write 3 digits in divided by 1,000. No, because that's just going to call write 3 digits on everything on, like for instance, like this one is going to call write 3 digits. This is going to give things that are more than 3 digits long to that. So that's not going to work. Change the recursive call write with commas to write with commas in modulus 1,000. No, because that's just going to give the last chunk every time, no matter what. That's not going to work. So I think that was a tough one. And I had to work it out to really even start to see what was going on. And I think that was a pretty challenging problem. The last one I think is kind of challenging also. I don't think it's as bad, but I think it takes a lot of focus and detail. So this one says sketch. It gives you int, and then n. So these look like x and y coordinates. It says if n is less than or equal to 0, it draws a line. Now, and I think down here it says assume the screen looks like a Cartesian coordinate system with the origin at the center, and that draw line connects these points. So that's what this is going to do. Okay, it's good to understand what it's going to do. You don't have to understand how it does it. Assume also x1, y1, x2, y2 are never too large or too small to cause errors. Which picture best represents the sketch drawn by the method called this? Well, I'm gonna trace it out. I'm gonna say, okay, well, if I call sketch A0, negative A0, 2, and I'm gonna draw a picture over here. Now it looks like all these pictures go. A seems kind of generic. But I'm gonna see if I can figure this out. And by the way, just as a preview, I'm gonna be able to figure it out on the very first step. I don't even have to finish this problem just because of the choices I have, process elimination. I'm gonna actually be able to find it sooner than I would if I had to go through the whole thing. But I'll go through the whole thing: x1, y1, x2, y2, and this is n. It says if n is less than or equal to 0, draw a line. Well, we're not there, right? N equals 2. So then. Otherwise, then it creates a new integer xm, which is x1 plus x2 plus xy minus y2 divided by 2. So this is going to be 0, right? Okay, and then it has a ym, which equals y1 plus y2 plus x2 minus x1 divided by 2. Well, that's going to be negative a. And then what it does is it calls sketch. And it calls sketch with the x1 and y1 of the current call. And then it uses these new two numbers, 0 and negative a. And then it decreases n by 1. So this is where we're going towards the base case. Now this call says, oh, well, is n less than or equal to 0? No. So don't draw anything yet. You're going to create a new xm. And this one's going to be x1 plus x2 plus y1 minus y2 divided by 2. Well, that's going to give you 2a over 2, which is a. And then it's going to be ym equals y, y1 plus y2 plus x1, no, plus, plus x2 minus x1 divided by 2. So that's going to give you negative a, because negative 2a over 2, negative a. And then that calls sketch. And it uses, so, I mean, we're still, after you call x, there's still another call to sketch after this. But once we call that, on right now, I'm only doing this first call every time I go through. I haven't gone here because this isn't going to happen until that's finished. And this doesn't finish until it's all wrapped up. So this calls sketch, and it calls x1, y1, so a, 0, and then xma, negative a, and then it decreases the n value by 1 to 0. Now, finally, we're at the base case, n is less than or equal to 0, and so it actually draws a line using these values, x1, y1, and this is going to be your x2, y2, and it draws a line. Now, a0 is right here, right? Is that a0? And a negative a is right here. So this is the first line it draws. Okay? Now, by process of elimination, do you see any graphs that have a line there at all? This is the only one that has it. So wrong, 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 wrong. This is the right answer if you're in a hurry. Let's see if we can finish it, though. I mean, just for understanding this, and see if we can actually maintain the level of detail and focus to pull this off. Now, after it does this, it goes to sketch, and it uses xm, a, negative a as the first coordinates, and then uses x2, y2 from that last call, 0, negative a, and it decreases it to 0. So we get to draw another line pretty quickly here. This draws a line from a, negative a to 0, negative a. And so a, negative a is right here. It picks up where it left off, and then it goes to 0, negative a, which is right here. And so that's the second chunk of line that gets graphed. And that matches that. No other graph here even has that line. So now, let's see where we're at. So we finished that, and then we go back up to here, and this calls sketch. So this is the XMY1, and then this is the first sketch, and that's the second sketch, and now we're done with that. And so we go to the previous call where we had called this, and so now we need to call sketch with this xm, ym as the first coordinates, and then x2, y2 are going to be those, negative a to 0, and the n value gets decreased to 1. And then this says, oh, is n less than or equal to 0? Nope. So you got to create another xm, ym. And so xm is x1 plus x2 plus y1 minus y2 divided by 2. is going to be negative a, and then yn is y1 plus y2 plus x2 minus, x2 is negative a minus x1 is 0 divided by 2. This one is also going to be negative a. So then it calls sketch, and it uses, the first time it uses the 0, the x1, y1 that was in this original call, and then it uses these two new guys as the next two. And it decreases by 1 to 0, and then says, and then it goes back and checks 0, and then now we actually get to draw. So we're going to draw a line from 0, negative a to negative a, negative a. 0, negative a here, negative a is here, and so it connects those. And then it goes back to sketch, and this time it uses negative a as the first two, and then it uses negative a 0 as those two, and then it decreases 0 and then 0, so we get to draw another line. And that's going to be from negative a to negative a 0. And here's negative a, and here's negative a 0. So it connects those guys. And that one's done. And then we go back up here and we're done. Wow. Can you do that? These multiple choice problems are crazy. All right. Anyways, good luck. Fill out the next form. We'll do another video soon for searching and sorting.